So I'm going to share just very quickly here. I'm going to have to pop back and forth on two pieces of things that are on two pieces of software here. Bear with me. So people should now be able to see my web browser. And for those that have not got a copy of ImagesPlus, ImagesPlus is now free. When Mike decided to retire and chase other goals, he made ImagesPlus a free download for anyone that wants it. So here is the website, www.mlunsold, Mike's last name, .com. And if you go there, you'll notice a bunch of links on the side. One of them is the free ImagesPlus 6.5 download. You can actually download the software free there, and it is a full functioning latest version, which is version 6.5. So now we're going to try and share another screen. With a little luck, this will work. Okay, so now people should be able to see ImagesPlus, I'm assuming.
Yep.
Okay, good. So we will get into a variety of mask-related topics tonight. Bear with me. I am just going to my tablet with all my notes on it. So there we go. So one of the things that takes a little bit of getting used to is when ImagesPlus first started, it had, I will be polite and say, the most god-awful user interface known to man. It has improved only slightly, so it's still a little clunky. However, its actual processing capabilities are top-notch. Mike, when he wrote it, he actually, his day job was like mine, signal processing and image processing and engineering, and came up with a really nice package for doing a variety of operations. And one of the things he added in the later versions is the concept of being able to work on parts of an image. And there were a variety of tools added to the software to support that. We're going to take a look at some of them tonight, and those are the tools to generate masks. I will be rather blunt in my comment here that if you are using ImagesPlus and you are not using masks in your processing, then you are not doing it right. They are that important in coming up with very nice final images. Now, I'll backtrack a bit on that and say you can do a lot of things without masks, but to get the best results, you really need them. So masks are hidden under the special functions menu under mask tools, and there's a whole variety of them here. For the most part, they work very similarly to the masks in Photoshop. There are a couple of minor differences, but it's good to know those differences because sometimes they will cause you some grief if you're familiar with Photoshop. The whole processing paradigm, if you will, in ImagesPlus is very Photoshop-like. It fully supports layers. It fully supports blend modes, masks, all those things that people use in Photoshop are available in ImagesPlus. We've gone through in previous sessions, how to stretch images, that sort of thing. And I've used masks a few times in those sessions, but the idea here tonight is to try and concentrate a little more on actually using the masks to get what we want done. So to give you an idea, there are several mask tools here. We'll go to mask tool, we'll go to mask tools. And, bear with me a second, there we go. So the first thing is save, then copy mask, and we'll talk about that one in a little bit. Most of these mask tools, by the way, are duplicated on the toolbar button on the side of the package. So the first one that we'll look at here tonight is a simple luminance mask. Now, Before I go into trying to explain masks, I'm going to ask a couple of questions of the people out there. First one is everybody familiar with the concept of a mask in image processing?
I am not good with it at all, to be honest.
I would appreciate it if you would elaborate.
Okay, fair enough. So a mask is nothing more than a grayscale image. Where the mask is white, 100% of whatever you are doing is applied to the image. Where the mask is black, none of what you're doing is applied to the image. And where the mask is an in-between shade of gray, it will do an in-between apply. So as funny as that sounds, basically you can imagine if the mask has half of its maximum value, then half of the adjustment that you just applied would actually be applied to the image. So I'll give you an idea of what I mean by that. And in order to give you that idea, I'm going to actually use the paint tools to draw a mask. So first thing we're going to do, I'm going to make a mask from the image that's on the screen here. So here's a mask. You can tell it's a mask because usually when you make a mask, ImagesPlus will give it the same name as your image, and then it will tell you the type of mask. So this is a luminance mask, and it's the very first luminance mask. Next one I generate will be, if I generate it from this same image, I'm pointing at my screen like you can see that. If it generated from this same image, this would then be number 2. So just so you can keep them straight. I do, however, tend to name them something that makes sense to me in my processing. I don't normally stick with the default name. So this is a simple luminance mask, but what I'm going to do, I'm going to make this mask 0 everywhere. So just bear with me a second. I'm just going to, where's brightness and contrast? I'm going to turn the brightness down a bit. And then I'm just going to limit everything so everything goes to 0. I'll get into what these tools do in a little bit. I'm just making our first mask here, so bear with me. Okay, there we go. We now have a mask that is completely black. And on this black mask, I'm going to paint something in the middle. I'm going to paint it white. Okay, I have to shrink some things down on my screen. Bear with me. There we go. So I'm going to paint a big white blob in the middle of this mask. And again, don't worry about the paint tools and everything here. We'll get into those eventually. It's not quite white, but it's close enough. Oops, I try that one more time. Can't click done until I click in the image, sorry. That's white. So now we're just going to paint a big white blob here in the middle. Close enough to a big white blob. There we go. Now we're going to save this mask. I'll just click save for now. So now we have a mask and it is saved under this name. So what we're going to do, I'm going to take this image and I'm going to stretch it. I'm simply going to brighten it up. We'll use an ArcSine stretch, one we've gone over in the past in a previous session. And once some galaxies pop out here, we'll turn up the background a little bit. And we'll turn the background up some more. And then I'll just brighten everything up one last little bit here. Okay, so now we have an image that's been brightened up a bit. Now remember that mask that I produced that had a big white blob here. So what it's going to do is when I apply that to this image, this stretch that I've just used is going to happen where that big white blob was. Everywhere else, the mask was black and there will be no stretch. So the way you apply a mask to an adjustment in ImagesPlus is you pull up the history window. You can get it under, I think it's modeling, no, sorry. It's under one of the menu items, but I just click the history window button and it will bring up this little history dialog. Now, ImagesPlus has an infinite number of undos, and every step in your processing until you do an image combine will show up, or a layer combine, I should say, will show up here. We're on this particular arcsine stretch right now. And if you want to apply a mask, you just click the mask button. It will bring up the mask surface dialog. You can select the type of mask. There are two of them, and we'll get into what each one does in a minute. But for now, we're just going to select mono image. Now, I can load that mask that I just made, or since I saved it with the Save Mask button, I can just right-click in here and select Paste Mask. Once you do that, you'll see the effect here pretty quickly. So you can see that the stretch that we had applied is now only being applied where the mask is white. And it's being completely applied in this area. In here, where the mask is black, the stretch is not applied. Everybody see that? Now we're going to do one more thing, just to give you an idea of what happens as you change the shades of gray. We're going to recall that mask. By the way, anytime you want to recall a mask, you just click the Display Mask button. Now we're going to blur that mask. And what blurring is going to do is it's going to leave it white in the middle, right in here, but it's going to blur the edges. And I'm going to blur it a fair amount here. Let's say, oops. Just to give you an idea of what a mask will do. So you can see here, by the way, down here is the brightness value. As I move my cursor around, you can see that here it's white. It's 65,536. Then as I move out, it begins to tail off, right? And it keeps going down and down and down, and then eventually should get to 0 once I'm out about here. So we're going to give that one more stretch, or one more blur rather, just to sort of blur it out a little bit more. There we go. So again, in the middle, it's still completely white. I'm now going to resave that mask. And I'm going to come back to this image. Now, you'll notice now the mask showing up here is blurred. When I click apply, it's going to apply this new mask to the stretch that we did. And I want you to watch what happens around the edge of this. You can see what it did. It blended it in. It actually followed the blur. So it's completely applied here. And then as the mask gets darker, it applies that stretch less and less to the image until when you're out here, it doesn't apply it at all. So that gives you an idea of basically how masks work. They allow you to tailor your processing to some point in your image. You can make masks based on brightness, spots in the image. You can paint the letter S for a mask if you want, and it will have a big stretched S on the screen. But it does give you an idea of how masks behave. Any questions so far? Reasonably straightforward? Okay. So now.
Now, is it better to, oh, 1 second, Blair.
Yeah, go ahead, Fabian.
Blair.
Yep.
Okay, is it better to always put a good like a blur on it like that, or is it certain, certain times you would do that?
You're jumping ahead. When you put a blur on, the mask really depends on what you're doing. So we'll get into that a little later.
Okay.
The idea is if you want to blend an effect that you're putting on some section of an image into the rest of the image, and you do not want a sharply defined line, then you want to blur the mask. When you do those sorts of things depends on what you are doing. So for instance, when you're combining images, you tend to have a blurred mask. When you are stretching an image, you have an unblurred mask. And again, we'll get into why you would do that in a few minutes. So you get the idea. You can see how a mask works here. So now what we're going to do, I'm going to close down that, and I'm going to delete these two items from the history list.
Was there any significance to the green border on your mask tool?
Sorry, Glenn, you're sort of muffled there. Try that again.
Was there any significance to the green border on your mask tool? Does that have it? Does that play into this at all?
Not really. The only thing that matters is the white area.
Okay.
The green border is to some extent because there are two types of masks, and that's sort of the next thing on my list here before we get into generating masks in detail. So I'm going to reapply. I got to shrink the video window down here again. Bear with me. I'm going to reapply that stretch to the image. Just take a second. And we're going to go back to the mask window. So this green border is what Glenn is asking about. And the short answer is it's the canvas upon which your mask is placed. So if you had a camera that had many, many more pixels than my camera, then you could conceivably fill that in, but that would be a huge camera. You know, this particular image is 5960 pixels wide. So, you know, you would need somewhere near 10,000 pixels wide to fill that. It would take quite a big image. So what we looked at was a mono image for a mask, or typically what's called an image mask. The other type of mask that ImagesPlus supports is called a control point mask. Now, control point masks have fewer uses than image masks, but for what they're designed for, they're extremely useful. So I'm going to look at one particular control point mask here, and then I'll show you how you can get different versions of it. But basically, these red dots represent the control points. So if I take this red dot and I move it toward the center, you can see what happens. The mask gets dark in that area. And look what happened to the image. You can see that the stretch was not as applied as much where the mask is dark. But now I want to really apply the stretch in the corner, so I can grab the corner and pull it away. And now you'll notice that the mask turns white in this area, and the stretch is really applied a lot in the corner, but I still have this darker area, and you can see it on the mask. You can do that with each of these control points. You can move them to darken an area by pulling them toward the center, or you can brighten an area by moving them the opposite way, away from the center. And you can generate a mask that way. These are very useful for doing things like maybe a little bit of vignette correction. They're also useful for applying a correction to another mask and limiting where it's applied. So suppose you made a star mask so that you would be able to correct some issues with your stars, but you only wanted the correction to occur in the corner. What you would do is you would, if I reset this mask a second, bear with me, you would go to a control point mask and you would turn these down everywhere in the corners. And you make the mask dark. Once it catches up, move my video window again. So now I have a mask that's dark in the corners and light elsewhere. If I took this mask and I had a star mask and I said, I'm going to reduce the brightness of the star mask to 0, it would only do it in this area. It would leave the corners unaffected. So now I would still have a star mask out here, and then I could use that to correct the corners of my image. I'd have to save it, of course. But that'll give you some idea of what a control point mask can do for you. There are several different types of control point masks. This particular one is called Reveal All. It lets you move any of the data points. There are several others, so I can select just the corners. once this comes up. Now I can darken a corner or I can brighten a corner, but the center points, I believe, if I remember correctly, are fixed. They're stationary. I can't move them. Same with this point. The only points I can now move are in the corners.
Blair,
Yes.
in terms of the operation of this stretched point surface
Yep.
as a mask, where are the limits of the original image within this now non-rectangular area?
That's the part that takes a little getting used to. They're not. What this is a representation of where the mask is white. So the mask is white in the corners of your original image. You'll notice the mask started off as square, even though my image is a rectangle. So it doesn't exactly correspond to the image. It's one of those quirky user interface things I was talking about earlier. But what it tells you is the mask is dark in the center and bright at the corners. And that's the effect you'll see in your image. You'll notice it's dark in the center and bright in the corners.
The four red control points along the bottom of the mask, all
these four here?
in reality, yeah, all in reality are along the bottom of the image.
That is correct, Jerry.
Okay. Yeah, all right, got it.
That does take a bit of getting used to, I must admit.
So the mask definitely doesn't cover the entire image.
Sorry, say that again, Glenn?
The mask itself doesn't cover the entire image. It's something you have to guess at where it is, roughly.
The mask does cover the entire image.
Okay.
So what Jerry said is correct. This point,
Right.
this point, and this point are, if I shrink this image down, this corner, right about here,
Oh, okay.
right about here, and then this corner.
I see. I understand.
Okay, it's one of those user interface. What's that?
It proportions itself to the image.
That is correct. So this is a graphical representation of where the mask is bright and where the mask is dark. It is not a graphical representation that, however, that you can lay right over the image. It's one of those user interface quirks, but it once you get used to it, it's not bad. You can further fine-tune the control of a control point mask because I can select which of the points I allow to actually be controlled. So you can see, you can set, I'm going to adjust the corners, and then you can say, I'm going to adjust the corners, but I'm only going to take the two bottom corners, right? You can, do the bottom area to the left, which will sort of leave these points adjustable. There's all sorts of combinations, but in truth, you can do all the combinations with a simple flat reveal all one, because now you can move any of the points. However, that will give you an idea of the other type of mask that is supported in ImagesPlus. They're of limited use, but they do come in handy for some things like vignette correction, as an example. So for, if I wanted to correct the vignetting, I could use a curve to brighten up the corners, and I don't want that curve to be applied in the middle. So what I would do is I would darken the center area. Once this does its thing here. And then I could say, but I really wanted applied a lot in the corner, so then I would stretch the corner. And now you get the idea that the curve would brighten up this area, and then it would blend into the rest of the image. So they're quite useful for things like that, but generally I don't tend to use them too much.
Blair, it would make sense, at least as I see it, that you'd want to do certain things before you build this kind of a mask. You'd want to have, first off, you'd have to crop. And I noticed that there is a crop already on this.
Yes, I've already cropped this image.
Yeah, so the mask would apply only to what the image is. If you
That's
made
correct.
it smaller or larger, what happens? Does the mask move eventually, or does
Nope.
it stay?
The mask always scales to a control point mask always scales to an image.
So whatever the image is that you're working on, okay.
Whatever image you're working with, this is always the bottom left corner.
Okay.
right? Now, if you crop an image and you apply a mono image as a mask, it must be the same dimensions as the image you're applying it to.
That makes sense.
Okay, so now we have an image right here. A couple of things have happened, and I'm going to sort of overdo the stretch on this to make the point here. Bear with me. Once it does its thing, we'll do a little bit of an expansion. There we go. So now we have a really bright image. You can see the companion galaxy here is starting to show up, and at least on my screen, some of the IFN is beginning to pop through. But the image here is kind of got a really bright sky background. There are ways of taking that down, but one of the simplest ways is, now that I've stretched it that much, let's make a luminance mask. Once it's done. So here's the luminance mask, and all it is a grayscale version of the image. Everybody see that? Now you can picture what's going to happen. If I apply this mask to the stretch that I just did, anything that's bright in the image is going to be brightened. Anything that's dark in the image, in the mask, right, will be brightened less. So let's watch what happens. If we just store that mask, you'll notice, by the way, since this is the second mask I've generated from that image, there's that number 2. Now we're going to apply that mask to this image and watch the effect. Again, I select mono image. I right click and say paste the mask. And look what happened. The galaxies are now brightened. The stars are brightened, but look at the dark background I've got. Now, that's a very extreme case. I would play around a bit with that mask, brightening it up a bit to allow a little bit of brightening in the background, but it does show you how you can impart detail. So you notice you got nice, sharply defined spiral arms here. Let me just zoom in a bit. The stars are nice and round, and you got reasonably good detail in the galaxy.
When would you not want to do this rather than doing it all the time?
Sorry, say that again, Jerry?
First glance, it looks like you'd want to do this all the time. When would you not want to do this?
There are several times that you might not want to do it. It really depends on the kind of processing you're doing. But one of the things you'll notice is if you look at this image, the background is almost black. None of the IFN is visible anymore in this image. So that's a good reason not necessarily to apply this kind of a mask to your first stretch. You might want to apply it to the other stretches.
You could have just lightened that luminance a bit, right? You could have stretched the luminance mask.
That is exactly correct. And it's funny you should mention that. Watch what happens here. If we apply a curve adjustment now to the mask. So I'm going to lighten up the dim areas of the mask a bit. There. We'll save it again. Now we'll come here. You notice the background of the mask is now much lighter. And lo and behold, the background here will get a little bit lighter when I apply it. Can everyone see that very slightly increase in brightness? But one of the nice things it did was all of the noise that was showing up because of the excessive stretch in the background is now well controlled. Remember how I said if you're not using masks, you really aren't doing it properly? Look at the background, how quiet it is. It's because there's no.
I wish I had had this last night.
You were processing something, were you?
Well, today I did, and it's yeah, yep.
But you get the idea. All I did was I took the image and I stretched it originally. And if we turn this mask off, here, we'll use the mask for just a minute. Now, I don't know, can you notice the noise in the background there now, Jerry?
Oh, that doesn't look like mine. I have much better noise.
Let me see if I can make that noise ridiculous here. then we'll really up the stretch a bit. Okay, now you should be able to begin to see some of that noise in the background. Let it do its thing here. Okay, there, now you can see it, right?
Yeah, blotchiness.
Yeah, exactly. So now what we're going to do, we're going to apply that mask again. Use mask. Watch what happens. Notice how it went way down. There's still a little bit of it there, but it's much improved.
I gotta go now. I'll be right back after I process.
Okay, so you get the idea. By using that mask, I've limited the amount of stretch that happens in the background, right? And if I take that mask, you'll remember we brightened that mask up. Let's darken that mask a little bit now. Did I happen to leave that curve open? I did, good. So I'm guessing that I can take that background down about like that. Yeah, maybe a little more. Get back to somewhere near the original mask. There we go. It's not perfect, but it should be close. And again, we'll apply it.
Wouldn't the original mask have been linear?
No, the original mask was actually a mask of an image that had an arcsine stretch applied to it.
Right.
ImagesPlus does not get carried away with linear versus nonlinear at all. Matter of fact, completely ignore it while you're working in ImagesPlus. In PixInsight, they tend to go on and on and on about what should be done linearly and what should not be done linearly. And mathematically, they are correct. However, the net effect, if you're trying to make a pretty picture, it makes no difference. Deconvolution is a good example. Everybody says you cannot do deconvolution on an image that is not linear. Now, I'm sorry, you certainly can. It may not be exactly mathematically correct to do so, but if you're making a pretty picture and not making a scientific measurement, then feel free to do it whenever you please. Whenever you see something you want to sharpen, sharpen it. And ImagesPlus specifically goes out of its way to not make any of those distinctions. As a matter of fact, there isn't even a screen stretch available in ImagesPlus. Anything you do is done to the image. Now, you can see what happened. Now we have this nice, reasonably clean background, and we have some well-defined galaxies. Now, I don't know if anyone can see it, but can anyone see that little black area or darker area right there?
Yep.
That's a dark area, which is part of ARP's loop in the IFN, and you'll even see there's an arm of the IFN going out this way, all just from a stretch and limiting how much of it I apply to the background. Of course, the galaxy itself is quite bright, and as a result, it doesn't have a lot of noise to begin with. So the mask allows the full stretch or a big chunk of the stretch to come through on the galaxy. And because the mask is made from the image, it blends everything together quite nicely. Now, someone asked when you should, I think it was Fabian, asked when you should blur a mask. You don't want to blur this mask. I'll give you an idea of what happens if you blur this mask. So let's blur it. We'll blur it by a fair chunk here. Maybe even a little more. Okay, there we have a blurred mask. I'll save it. I won't close it so I can undo the blur in a minute. And now we'll apply it again with a blurred mask. Watch what happens to the galaxy. See the galaxy blurred out with the mask? This is one of the differences between ImagesPlus masks and Photoshop mask. In Photoshop, you can apply a mask to an actual adjustment layer. In ImagesPlus, that doesn't happen. What's happening here is there are inherently two layers in this image. There's the base image, which was the original image that I started with before I applied the adjustment. And then there's the adjusted layer, and the mask sits on the adjusted layer. So as a result, I've brightened the image, and sitting on top of it is a blurred mask, which means that the brightened image is blurred as it combines with the image underneath, and that produces this blurred out galaxy. So when you're using a mask to do a stretch, you do not want to blur it. Does that give you some idea, Fabian, of when you would and would not want to use a mask? Okay. Now we'll undo the blur here. No, maybe we won't undo the blur. I'll have to regenerate the mask. That's easy enough to do later. So you get the idea of how you can use a simple luminance mask. Let's pull up that image again.
Sorry, Blair, just
Yeah, go ahead.
I know my audio on this is a little bit bad, so sorry about that. But
That's all right.
first of all, you were saying IFN. That's not
Yep.
a term I'm familiar with.
Oh, sorry. Integrated flux nebula. The IFN is actually an intergalactic cloud of gas and dust that exists between us and several objects, in particular M81 and M82.
Okay,
And it has tendrils of gas throughout the whole field.
fair enough.
Okay.
The other question I had, when you made that luminance mask,
Yep.
well, that was awesome what it did to your image when you just applied it without changing anything.
Yep.
Could you brighten that luminous mask a bit, and would it brighten, like, would it give you more detail in the galaxy?
The short answer to that is absolutely. You can apply any adjustment you want to a mask to brighten up some area that you want to brighten in your image.
Isn't that only relative to the fact that once it's, pure white, you can't, if the mask is white, it can't have anything else.
That is
You're
correct.
having a full effect. Yeah.
That is correct. If the mask is actually white in some area, then the full adjustment is applied at that point.
Would it make those spiral arms sharper though if it was more white before the mask is applied, if you know what I mean?
Not necessarily. You can make the spiral arms stand out more. So for example, if we pull that mask back up here, so let's regenerate the mask. Oops, sorry. I gotta shrink a video window, bear with me. So let's just not go quite so crazy on that stretch just yet. There we go. So now we've got our galactic detail back. We'll make a mask out of that. We'll save it. And the same thing, we're going to apply it to the stretch. Now, since I'm going to apply the mask, I can go nuts with the stretch because I will control it better once I select the right image. Okay, and we will turn up the spiral arms a bit. We'll turn up all the fainter detail a little bit here. And now we'll apply that mask. So I'll make a mono image. There we go. So now you can see you have a nice dark background here, a little too dark. You have spiral arms. So let's turn the background up just a little bit. What I'm doing, I've applied a bigger stretch to the darker areas of the image here. So even though the mask is limiting what happens, it brings the background up a little bit because the mask is not absolutely black in those areas. I'll show you what I mean in a minute here. Okay, so here we are here. We have an image. The background is starting to come up. you look, the mask is controlling the background. If you want to see what it looks like without the mask, you just click off the Use Mask button, and you can see that the image is grossly stretched. Now, one more thing you can do with a luminance mask. Now that you have this image, so let's say you've stretched an image and the background is a little bit brighter than you want. You can do the opposite of, let me just turn some color up here so we can continue to pull it out. Turn the reds and blues up a little. So one of the things you would want to do with this image is you'd want to darken some of the areas. And ideally, you'd want the integrated flux nebula to begin to show up even more. So let's take that mask that we just looked at, which is right here. Oops, which will be right there once okay, so here's the mask. And one of the things we'd like to do is maybe take this mask and stretch it a little more, which is exactly what Fabian, I think it was, just asked there a minute ago. So let's just apply a little, set this, we'll apply a little stretch to the mask, and we'll limit the stretch to leave the background alone a little bit. All I'm trying to do here is force some of the IFN to show up. Turn that up a little more. Okay, now can everyone see that sort of bright arm right there that sort of comes around that way? Hopefully that's showing up. It's obvious on my screen, but it might not be on the Zoom with Zoom compression. Can you see it's a little lighter here than in the middle right here?
Yeah.
Okay, and you know, it's darker down here, those sorts of things. So it would be awfully nice if we could apply a stretch like this where we darkened the dark areas and left the bright areas alone. So we don't want to darken the spiral arms or the galaxy, but we'd like to darken the background a little bit. One way to do that is to take this mask and we're going to invert it. There's a couple of ways to invert it, but the simplest one is just say negative. Now we have a mask where the galaxies are dark and the sky background is bright. We're going to save that mask, but this time I'm going to put the letters INV in it so I can distinguish it later. It's a luminance mask, but inverted. Now what we're going to do, we're going to come back to this image here. I'm going to reset this stretch. Okay, so what I want to do, I want to darken the background, but I want to leave the galaxies untouched. So what we're going to do, we're going to do a curve adjustment, and we'll dial down the background. So now the background got darker, but you notice the galaxy got dimmer as well, right? If I undo that. Okay, you can see the galaxy spiral arms are all the way down here, but once I do that stretch, now you can see the galaxy has reduced quite a bit as well. What we're going to do now, we're going to take that inverted mask and apply it to that stretch. And that will limit how much of that stretch gets applied to the galaxy, but it'll still make the background dark. So you can see now, we can actually dial the background down a little more and still preserve the galaxy. There you go. So now you have a galaxy. The background, however, is nice and dark. So you can see you can use a luminance mask two ways. You can use it to brighten the bright areas, or you can use it to darken the background and limit that so you don't darken the bright areas as well. Make sense?
Not really.
Not really?
I'm not sure why reversing it is that significantly different than just applying the original?
In this particular example, it didn't do much, Jerry, because the image is pretty clean. But if you have an image, for instance, that has a noisy background and you want to turn the background down and leave the galaxy untouched, then you can play with the mask. So for instance, we've got a mask that looks like this. I can say I want to turn the background down even more. So I can go to, for instance, a levels tool, and I can protect the galaxy some more by making the galaxy darker, as you just saw. And I can make the background whiter. Right now, when I apply it, if I save it first, hopefully you'll see a little more difference. There, you see the galaxy brighten up and the background got dark? So you got that versus, oops, wrong one. So there it is without the mask applied. You can see the galaxy got dark. If I apply the mask, watch what happens. See the difference? You've still preserved all of the detail, for instance, around M82, but you made the background dark. Whereas if I don't use the mask, the detail around M82 tends to go away.
But in the first case, you had applied a black, a non-inverted mask, and that in essence darkened the background.
No, in actual fact, what the non-inverted mask does is it limits the brightening to the bright things in the image.
Right. Okay.
Now,
all right.
I
So
may
this was
want to
actually darkening the black, the dark.
correct. It just didn't brighten the background. But by inverting that mask, as I've just done, I can actively darken the background while leaving the galaxy reasonably untouched.
Right. So the first step brightened the brights.
Yep.
And without touching the darks, and this is the reverse. This the second step darkened the blacks without touching the lights.
And then the next step takes the darks down.
Yeah.
So that'll give you an idea of how you can use a luminance mask in two different ways, just by simply inverting it. And of course, then you can stretch the mask any which way you want. Okay, everybody following me to that point?
Yeah, Blair, Kevin here.
Yeah, go ahead, Kevin.
I think a lot of your effects are a lot more subtle across the Zoom link, as you're saying, due to compression and other things. It's not quite as clear as it may be on your side.
Oh, I completely agree. Zoom has a nasty habit of adding a lot of compression.
Yeah, the last two images, when you applied the mask and you were saying the background was getting darker, on our end, it actually looked brighter and splotchier than it did previously. So
That's not surprising given what Zoom does. If I take the mask off here, you'll notice the background is dark, but the galaxy got dark. Now, when I put the mask on, the background should remain dark, but the galaxy should become brighter. You see that difference?
yes, we can.
Yeah, so that's the effect. I do understand exactly what you're saying about the background will get blotchy. That is a function of Zoom, unfortunately, and we can't turn their compression off, which tends to limit its use for these sorts of things. But at any rate, that'll give you an idea of what's going on there. Next thing we can do with a luminance mask, it's not necessarily the absolute best way to do what I'm going to show you, but it'll give you an idea. We'll close that window down and we'll bring up the image again, same image. And again, we'll put a somewhat ridiculous stretch on the image, much more than you would ever apply in one go around here, simply to bring out what it is I'm going to show you, the noise in the image. Whoops, maybe not quite that much of a stretch. And I'm going to turn the background level down a bit, which will make it look even noisier. Okay, So now, can everybody see the noise in that image?
The blotchiness, yeah.
Yeah. So there's another thing you'll notice in that image. You notice there's a shape right there, and it sort of extends all the way up there. There's what looks like, it looks very noisy, but there's gas and dust throughout the whole image. Can you see that?
Mhm.
Okay, that's the IFN in case anyone is curious. Now, the image is really too noisy at this point. So if we sort of zoom in here, now you should be easily able to see the noise, including a satellite that was right through the whole image right there. Everybody see that? Okay, what we're going to do now, though, is we're going to take that image, we're going to make a mask out of it, and it's going to be an inverted luminance mask again. So now I'm going to invert it. Oops, negative. And I'm going to stretch it. Levels is one of the easier ways to do this. And the idea is that anything that I want to protect that may have detail in this image, the stars, the galactic arms, that sort of thing, I'm going to make as black as I can within reason. So there we go. Now I'm going to make the background as white as I can, again, within reason. That's a little too much. There we go. So now you can see you've got a white background. You've got the galaxy. You can see the spiral arms a bit. And all the stars, or at least most of the stars, are now black. We're going to save that mask. And I'm going to stick the letters NR after this for noise reduction. Now, one of the things that happens when you start reducing noise in images, almost any noise reduction routine blurs an image to one extent or another. And the problem is you don't want to lose all of the detail that you work so hard to capture in the spiral arms. So for example, here's some H2 regions in here, right? You can see all sorts of detail right into the core if I hadn't quite stretched it that badly. But this noise is really disturbing. So we're just going to use a simple low-pass filter to get rid of all of that noise. The unfortunate part is it'll make the galaxy blurry too, and it'll blur out a lot of the stars. So we'll just wait for that low-pass. This low-pass filter is done in the frequency domain. We looked at some of those in the previous session, if I remember right. It'll take a second or two to run. I should have binned the image so it would run much quicker. There we go. So you can see the background is starting to get better, but you can see what it did to the galaxy. We'll even blur it a little more. Take as much of that background down as we can. There's one other kind of noise reduction I have to add to this to take out the really high frequency noise, but we'll get to that in a minute. Okay, so now we have an image that has much less noise if you look at the background, but lost all the detail in the galaxies. So what we can do is we can apply that mask that we just made and watch what happens. Now I have all my detail back because the mask is dark and it's preventing the blur in the galaxies and the stars. But look at the nice job it did on the background. Everybody see the difference? Right, so if we come to here and I say, turn this down so we have a noisy background. There's the noisy background. Now we'll bring the adjustment back. Now I've quieted the background down, and look, you can even make out the IFN now. Right? Everybody see that? So that's a simple way to use an inverted luminance mask to protect areas of the image that you do not want to blur with your noise reduction. Right? now what I've done is I've tailored the noise reduction to the dark areas of the image by virtue of making a mask, a luminance mask, and then inverting it. So what is light in the image is dark in the mask. Fabian, you're scratching your head there. Okay, good. So everybody follow that so far? Good.
So,
So that gives you an idea of how you can use a mask to tailor your processing to some aspect of your image. We can now take this same image and watch what happens if we take back to a levels adjustment and we just turn the blacks down a bit. And we wait for it to process. Oops, I gotta pull the image back. Now look at it. Now you can really see the IFN stand out. I probably pulled the background down just a little bit too much. I probably shouldn't have used a level. I probably should have used a curve. Let me just nuke that. Love the cat, John. I'll have to get my dog out here. He can look at that and go nuts.
He's hard to ignore. He's a 21-pound tabby.
Oh yes, I know the feeling. So at any rate, you get the idea. Now, Jerry, you had asked about why I would use an inverted luminance mask when I turn things down. Let's see if this one will show why I would do that. If we make a luminance mask out of this image and I invert it. Now I'm going to stretch this mask a little bit, probably use curves, I think would be a good choice. What I'm trying to do is to get the IFN to show up in the background here. Bear with me just a minute. Okay, and now we're gonna, not quite. There, okay, now the IFN is beginning to show up in there. We could stretch this mask to really enhance the IFN detail that's here. So if we do that, use some other stretch functions here to bring out what I have in mind. And then we'll turn down. I'm trying to get the IFN to pop out in the mask a bit here. Just bear with me.
can see it now.
You can start to see it. It's not quite popping out as much as I would like, but it is there at any rate.
Blair,
Yes, sir.
If I'm looking at the screen to the right, there's about an inch on my screen anyway. To the right of the galaxy of 81. What is that?
That's another galaxy.
Okay, I wasn't sure whether it was gas or not.
No, it's another galaxy. I forget its designation offhand, but it's a faint galaxy that shows up when you really stretch an image of M81.
Okay, thank you.
I was gonna say it's the first time I ever noticed it.
Yep, no, it's there.
Yeah.
I'm attempting to really bring out as much of the IFN in this image as I can. So just bear with me a minute. I don't know that I'm going to get enough out of that. What I was going to try and do is if this area here with ARP's loop, as you can just barely see it there, you'll notice it's a little bit darker than the rest of the image. So if we store that, let's see if I can use that to actually enhance the IFN a bit. It would probably take a couple of cycles of this, but let's just see what we can get.
Blair, could you, if you had a region of interest, could you just paint on the mask to, shall we say, overwork that one area?
Absolutely, John. And in that case, when you paint over it, you would definitely want to blur the edges so that it blended in properly. But the short answer is yes, that's exactly what you can do. So I'm going to attempt now to darken the background a bit. And now if we apply a mask to that, let's see, Jerry, if this will, I don't know that I had that mask stretched enough, but let's just see what happens. There we go. It did make a little difference. Can you see how the IFN is now a little bit brighter relative to the background? Hopefully that shows up in the zoom compression. What it did is it highlighted the IFN because it took the dark areas like here and down here, and it allowed me to darken them more than the IFN itself. I'd probably have to do a couple of iterations of that to come up with a mask that would work really well. But that gives you an idea of how you can use an inverted luminance mask. Now we've got a noise reduced image. We've taken down the background a bit. We've got the IFN somewhat visible. We have a terrible green cast in it. You don't use masks to fix that, but there are lots of tools in ImagesPlus to fix that. Just like anything else, you can use the color balance tool and click on what should be a white star. I'm not 100% certain which star should be really white in this. I'd have to go look, but let's say that one. And hopefully that will help with the color balance here. Let's just see. And then you want to neutralize the background. So we want to take that down to a neutral gray. That took a little bit of the green out anyway. So now we've got an image where we have a decent looking galaxy, but it's not really as sharp as we'd like, right? It's not bad, but it's a little bit blurred. And if I apply sharpening, I'm going to bring back a lot of the noise in the background that I had just gotten rid of. So as an example, let's say we're going to do some sharpening on this image. And we'll turn up the fine detail here a bit. You can see the galaxy got a little bit sharper. Turn up the slightly less fine detail. But look at what happened to the background, right? Now there are several ways to avoid that. One is to use a luminance mask because you only want to apply sharpening where the image is bright. You don't want to sharpen the background where you have all the noise. So simply applying nothing but a standard luminance mask to that will help. It's not a perfect solution, but it does help. So I'll give you an idea. We'll just make a simple luminance mask. Now I would normally play with that and use one of the blurring functions. By the way, when you're noise reducing, it is acceptable to blur the image at least a little bit, to blur the mask rather. So if we blur this a little bit, just to take the noise down in the mask, and we wait for it to finish. There we go. We'll store that. Now what I'm going to do, I'm going to apply this mask to the sharpening. What should happen now is all of the stars should get quite sharp. The galaxy core should get sharp. It should begin to tail off in the arms because the mask is darker out here than in here. And it should really limit what happens in the background. Let's just try that. I might have to stretch the mask to make the background a little darker, but let's see what happens. So now we have an image. If we take the sharpening down, now I don't know, that wasn't too visible. It was a little visible here. I don't know if it's showing up in Zoom or not. So now I'm bringing the sharpening back. You can see some increase in detail here and here as an example. So I'll turn it off and look at what happens here. Everyone see that got slightly blurrier? Maybe if I zoom into 100% here. I should have used a slightly different sharpening tool that will make it more obvious, but anyway. See the difference? A little hard to tell. Let's try a better sharpening tool here to really make this show up. We'll undo that one.
I think
Yeah.
at the top of the galaxy, we could see a difference for sure.
Yeah.
One of the arms at the top.
Yeah. I'm hoping, let me just close down a few windows here. I have a few too many open. There we go. So what I'm going to do now is we'll use, even though it's listed as we'll use a high pass filter. And then I have to switch that to a soft light blend mode, and we should get a much sharper galaxy. Okay, so let's see if that becomes visible now. So there's the sharpened galaxy. Here is the unsharpened galaxy. Can you see the difference there? I'll turn it back on. Okay, so you can see a change there. The spiral arms become a little more defined. Okay, so now same thing if I get a little carried away with that mask. Wait for it to do its thing. Oh, I might have had to go the other way. Let me see. Yep, went the wrong way. I want it to hit the finer detail. Okay, so now you can start to see some noise showing up here. There's a little around there. And if we now apply that mask, we should be able to limit where that happens. So now you can see you got no sharpening out there, but your core sharpened up. And I can now play a bit with this. Wait for it to do its thing. There we go. So now if I turn that down, so now here's no sharpening. You see how the spiral arms got dim, but it's nice and quiet out here. Now we'll sharpen it back up with the mask applied. Watch the spiral arms, they got sharper, but we still did not increase the noise out here, right? So you can use a simple luminance mask to limit your sharpening to just the bright areas of an image. There is an even better way to control both noise reduction and sharpening in your images. And Fabian, you should be able to see that galaxy here now that I've stretched it and noise reduced it.
Yeah.
Right there. There's also another little one right there. There's one here. There's a bunch all throughout the field. Another one there. One of the things you can do with sharpening is it would be awfully nice to be able to sharpen just the areas that form an edge in the image. So what I mean by that is I don't really want to sharpen anything out here. There's nothing to sharpen. But here I have a line in the image. That's an edge. And it would be really nice to be able to make that more apparent. So one of the ways to do that is to use another mask tool called an edge mask. And there's a variety of different types of edge masks, and I would suggest you experiment with them, but the one that works the best for me is the Dorici mask. So what this does, this lets me turn the brightness of the mask up. And now you'll notice that it's only the edges that are showing up in the masks. You notice even the stars have the centers blown out because there's no edge there. But I can make that much by sliding the slider to the left here. I can pull up the edges much better. You see, I'm starting to define now the edges in the galaxy. And I can get a little carried away with it here as an example. There we go. So now only the edges of the spiral arms are visible. All of the star edges are also visible, and normally I would do this after removing the stars in the image. That's the job of the feature mask tool, but we'll take a look at that a little later.
Okay.
So we're just going to apply it like this. So there's an edge mask now. And we'll apply just the edge mask to this sharpening. You see, we still kept the spiral arm enhancement, but we didn't do anything out here now because there's no edge there. You can see in the mask, it's actually dark in that area. So now let's see if I can see if this will show up over Zoom. There, did you notice how this just got much fainter? If I now reapply the sharpening, but with the edge mask, this will get more apparent, but I did nothing out here, right? So now look out here. And again, we'll get rid of the sharpening. And other than the stars, which of course have edges, nothing changed out here. So edge masks are really good when you want to sharpen some detail. They're also really good when, if this area of the galaxy was noisy, I could take an inverted edge mask and it would be dark where all the edges are, so it wouldn't remove the detail, but when I get out in this area, it would quiet it right down.
I interrupt for a second and
Yeah,
ask,
away.
there's the bright star at the very top center.
Right
Below
here,
that, yeah, below that, is that a double star?
that is a double star.
Yep.
Yeah, okay.
Yeah, I've just stretched it to the point where it got so big that the stars actually blend together a bit.
Yeah, okay.
Okay, so that'll give you an idea of how to use luminance masks and how to use edge masks. Now, it would be awfully nice to, at the very least, reduce some of these stars. There's a way, excuse me, built in ImagesPlus to do that quite nicely, and I'm not going to use it here. I'm going to show you another mask tool. There's something called the custom luminance mask. What it's going to let me do, once the image shows up here. Boy, Zoom takes a lot of background processing power. When I'm not running Zoom, this is actually quite quick. Okay, so here's our mask. What I'm going to do by using the custom luminance tool, if I pull the maximum down, what it's going to do is, once the maximum gets below the level of these big bright stars, they're going to become black. So this bright stuff here in M82 is going to go away. And what I'm trying to do is I'm trying to leave the spiral arms. So you get the idea. If I bring this down here, notice what just happened? Most of the brightness around the stars went away. And I can do the same at the other end. I can remove stuff at the bottom end with this tool, or with this slider rather. Once that finishes, you have a feather control to sort of blend things together a bit. And finally, you can blur the resultant hiccups. You can blur the resultant mask. Since we are sharpening an image, it is okay to blur the mask to reduce some of the crap that goes on out here. Now you can see what you've done. Rather than have those big bright things around all the stars, they're really dimmed down. They're not completely gone, but they are at least dimmed. So now I could apply this as my sharpening mask, and I wouldn't make the stars quite so sharp. You can see the difference between this and this. right? Look at the, you know, the big bloated stars here. I might get a little ring out of this, but since it's sharpening, it won't show up much. So that's how you'd use the custom luminance mask. You can actually only make a luminance mask out of certain brightness levels and leave the others black just by adjusting these sliders. You can also pick from the image. So if I said everything below this brightness right here, I want black, I just click on that and it sets the slider for me automatically. You notice the slider moved down here. Right, so I said everything below this level is going to be black. See the slider slide down to that level. Okay. There's another similar mask to that, which lets you do the same thing. So you can make things brighter, or you can limit where your mask shows up, but it adds in the concept of color as well. And that's called a selective color luminance mask. So now I have the same controls that I had in the custom luminance mask, but I can also base it on color. So for instance, if I only wanted, shrink this down a bit, if I only wanted things that are the color of this star, I can click on that star. And once it finishes, it's still going. That star was red, and you'll notice it selected the red hues here. You can adjust that. This is the feather control, and this is the lower edge. This is the upper feather and the upper edge. But now look at what happened. With that image, I've only selected the things that are red. And furthermore, if I only want the red things that are dim, now I can slide this slider down, and all the bright red will go away if I slide it down far enough. So you can see the effect. Now I've only got a mask that is the dim red parts of the image. You can see where that can come in handy if you want to enhance a color in an image. If I wanted to dial up the reds in the HA regions, for example, I could use that tool to do that. It's pretty useful, but also a little fiddly. Sometimes you have to work quite a bit at adjusting the sliders to get the effect that you want. It's one of the mask tools that Mike screwed up on. By the way, Mike is Mike Unsold, the author of the package. You notice what happened. It made a mask out of the image, but you notice it's not a grayscale image. I can't use that as a mask. It's got to be a grayscale. So all I have to do is I take that and I make a luminance mask out of it, and now I have a usable mask, which I can then save. It's a mistake on Mike's part, and since he's no longer writing the software, he doesn't worry about it anymore. Simple workaround is just simply make a luminance mask out of it after you're done. Just undoing it now so we get our image back. There we go. So we've looked at how to use masks to limit where you sharpen, how to use masks to limit where you brighten. One other thing that is really handy is the ability to make a star mask, which is a mask of basically just the stars or things that look like stars in the image. So for example, ImagesPlus has a very nice star reduction tool. Star size and halo reduction. So I click on this, watch what happens to this big star. And all of the stars for that matter. Takes it a second or two to run. And I'm just using the default settings here. So that star got smaller. So if I undo that correction, watch this star. See it get a little bigger? Right, and now I can make it a little smaller again. And now I can make it a lot smaller, I think, by getting a little ridiculous with the adjustment. There. So everyone see how the stars got smaller compared to the unshrunk stars? Okay. The problem is that when you turn it down that much, watch what it does to the galaxy. It'll distort things a little bit in some areas that you might not want distorted. It turned down the HA regions and a few other things. So the way to get rid of that would be to apply this, but with just the stars highlighted in a mask. There is a way to do that. The tool is very poorly named. I actually wrote the algorithm for Mike for this tool and gave it to him, and he put it in. It's called the feature mask tool. And once this undoes the correction here, there we go. And it's not really a masking tool. It actually lets you split the image into stars and everything else. But it doesn't make a mask. They are still RGB images. So here's the feature mask tool. And this tool is probably, this tool alone, when you actually had to pay for ImagesPlus, was worth the price of admission. So for instance, I'll just slide this up a little bit here. We'll let it run. And you should see black spots where most of the stars are. Not all of them, but most of them. Once it's done, there we go. So anything that looked like a star in the image that was bright enough to be recognized as a star is now gone from the image. Furthermore, I can then just take a little more. I can just, here I am pointing at the screen again. I can just expand those a bit, as you just saw. I can protect certain areas so they don't go away with the, and we'll get into this more on another night, with the special star area processing. You just click this, click in the image, and then you can set the size of that. And then if I tell it to include that, now it won't remove that particular star. So if there was some part of the galaxy, like the galaxy core, that was being removed, you could protect the core. Let me just make that star go away again. So now I have an image where not all of, but most of the stars, as well as some points in M82 here, again, I would protect those normally, are gone. But I can recover those. All I do is I click split stars. And then once it's finished, now I have just the stars. If I now take that and do what's called a threshold operation, but just before I do, I'm going to undo that adjustment here so I get my image back. Then I'm going to make a mask out of this. So what we'll do is we'll say make a mask. It's a luminance mask. Close the original one there. So here's my mask. Now, ideally, when I do this star reduction, I want to be able to affect an area just outside the stars. So typically what you do is you threshold this image. Now, what a threshold does is anything above this slider position will be black. Anything below the slider position will be white. I might have that backward. Yes, I did, sorry. So anything below the slider position becomes black. Anything above the slider position becomes white. So now all my dim stars are now fully white. And I can enlarge those spots. There's a tool called star size reduction and smoothing. Basically, it's an erosion or dilation filter. And by using dilation, I can make those star points bigger. You'll see them get bigger here as we go. See that? Now I can save this as a mask. Getting a few masks. Now when I do that star reduction that we did, bring up the history dialog. We will now I can limit that star reduction to just the stars. So the stars are going to reduce here in a second. There we go. But I still distorted my galaxy just a little bit. Now what we'll do is we will apply that star mask. And now the star reduction will only affect the stars and not the galaxies themselves. And if I zoom right in on the galaxy, you can see now we still have all our HA regions. I haven't distorted any of this stuff, but the stars have been reduced. And it's simply a job of the star mask to limit the effect to just the stars. If you do that and you see some slight rings around the stars, I don't know if I got any on this one. Let me just check. Okay, let me dial up the adjustment so I get some artifacts here. Okay, now you can see a little bit of a dark ring around that star and around this star, and you can see it around this star. Especially this one, you should be able to see the dark ring. The way you fix that is you slightly blur the mask. So if I take that mask and I blur it just a little bit to blend things together, probably about that much, I'm guessing. And it's a little bit of trial and error when you do this. And we'll click apply. I better slide this over so you can see here. I'll click apply. And now most of that ring is gone just by blurring the mask a little bit. So if you overdo your star reduction and you start to see rings, you can actually fix that up just by blurring the mask a little bit. Now, you would never reduce the stars this much in one go. What you do is you take them down a little bit at a time. But I just wanted to give you an example of how you can use a mask to control the ringing that will show up around the stars. Any questions so far? Okay, we're just about through, I think, all of the mask tools except for some of the detail on the feature mask. And I think, let me just check that once that undoes that last adjustment. There we go. So we've looked at luminance masks. Lab luminance is just another luminance in LAB color space. You can make a luminance mask out of just the red channel, just the green channel, just the blue channel. We've looked at custom luminance masks, color luminance masks. This is the same negative function that's under stretch if you want to invert a mask. We've looked at edge masks. The other function here is an area mask, and really all that does is blur the mask to give you the opposite of an edge. So rather than getting an edge, it gives you sort of the overall brightness area, and we can take a look at that fairly easily as well. So if we blur this, you can picture what's going to happen. You're going to get a big bright area here, a bright area here, and blurry bright areas where all the stars are, as opposed to an edge mask, which only shows you the edges. So you can see it's exactly what it did. It's basically makes a luminance mask and then blurs it. Believe it or not, that can actually be useful. So that'll give you an idea of what that does. So the last remaining tool to take a look at, and calling it a mask tool is a bit of a disservice, is this feature mask tool. One of the really nice uses for a feature mask is it lets me process the stars differently than the galaxy. So for instance, I can, well, let's just use the same settings we had there. We'll do what we did. We'll make the stars disappear. Now, the catch here, I want to preserve a couple of places. I want to preserve these HA regions as well as the regions in M82. The way I'm going to do that, I'm just going to hit select. And then if I make the selection circle bigger, a little bigger again. So now I've preserved the core of that, and we'll preserve some of these HA regions here as well. I can put more of these protection circles in anywhere in the image I want. I can set them to either remove, in which case it will make everything inside the circle black, or I can set them to include, in which case it will make everything inside the circle. It won't remove anything inside the circle is what I'm trying to say. And I know I have to set this one to include here. Now when we do this, I should get all of these points. I think these are actual stars, but we'll ignore those for the moment. And I've got the core of this galaxy back now. Now what I'm going to do, I'm just going to slightly increase the size of my selection. And then I'm going to fill in the missing areas from the data around that area. And this should give me just some star halos and the galaxy. I can take the halos down more by selecting a wider mask area. There we go. So I can get that far enough that almost all of these will disappear. We won't go nuts trying to do that tonight. Now I can split the stars out of that image. Now I have two different images. I have an image that's basically the galaxy, or the galaxies plus the IFN, and I have an image that's the stars. The nice part about this is one of the problems with noise reduction is it tends to blur the stars. I can now overdo the noise reduction here without blurring out the stars because they're in another image, which I can then recombine. I would definitely apply a mask when I do it. And someone asked about, could I really tailor it by painting on the mask? And the answer is yes. And here's a time when you would do it. There are no stars in this image, just some big halos. I'm going to make a mask. It's a luminance mask. I don't want to blur the galaxy at all if I can avoid it. So I'm going to do a negative. I'm probably going to make the background blur quite a bit. So what I want to do is I want to say make the galaxy darker, maybe even a little more. And I'm going to make the background quite light. There we go. But I really don't want to blur this area much. So now what I'm going to do is I'm going to paint on the mask just to tailor it. I'm going to fill zeros in. I think zeros, is that what that is? Yeah, 0. I'm going to fill 0 in. Maybe a little bigger tool. By the way, the paint tools in ImagesPlus are square, not round. That's not nearly as much of a problem as you might think because you can make them 1 pixel across and get the tiniest of areas. Now what we're going to do, we're going to sort of paint out the spiral arms here. So my noise reduction that I'm going to do will not affect the spiral arms of this galaxy. At least not too much. Now, the one thing you're going to want to do is you're going to want to blur the edges of that to blend the effect together. And the paint tools also have a blurring tool. You have to be a little careful using it, but it should be able to just blur the edges to soften the effect at the edges a bit. Maybe do it again. Probably need a little more blur. I know it's hard to see that was actually blurring, believe it or not. We just want to blur it a little more. There we go. And again, I'm just blurring this so that the effect of what I'm going to do gets feathered into the image, and hopefully it doesn't produce too abrupt of an edge. And again, if it does, I just blur the edge some more, that's all. We'll start with that. So here we have the mask that I'm going to use. And I'm going to call this noise reduction mask. So now we're going to come to this image. Remember, there are no stars in this image. There are a few star halos. And we're going to use a different noise reduction tool here, just because. And we'll let it take down the high frequency noise that's still in that image. So did everyone see the high frequency noise go away there? If I undo it, look in this area in particular. You see the difference? Is that showing up in Zoom?
Wasn't really that obvious to me.
Okay, let's see if I can show it to you this way. Can you see a little bit of noise in this area? Is it visible? Okay, now we'll put that noise reduction back in. Notice it's all gone. You see the difference?
Not noticeably at all, sorry.
Sorry,
I
say
can
that
see
again,
it.
John? Sorry, I didn't catch that. What did you say?
It's not very noticeable from
Yeah,
here.
let me see if I can find an area that happens to show the noise a little more. Okay, look in this area.
Can
Can
see
you see
that.
the noise? There's even a couple of little lines in there. Then when I apply now when I apply that filter, you see it gone?
Yeah.
Okay. But look what it did to the galaxy. Blurred it right out. However, we have a mask that we made. So there's our galactic detail back. All of the high frequency noise in the background is now gone. And if I had stars in the image, the stars would also be gone. But there weren't any stars in the image. They're all in this image. Now I can recombine those two. Hopefully they're in the right order. They usually are. And now I have all my stars back, and I have that really super smooth background. It's actually too smooth. But you notice the stars didn't get damaged because they weren't in the image to begin with. So that gives you some idea of what you can do with the feature mask tool, but you can go even further. I'm going to get rid of this image. So now we have noise reduced this image. Now we could sharpen it. And there's a very nice function for doing this sort of thing called multi-scale decomposition. This is going to do two things. It's going to emphasize the galaxy compared to the rest of the image. Again, not the purpose of tonight's session, but the problem with doing it, this is going to take a second or two to run. The problem with using this tool is it will really emphasize the background noise. So what we're going to do is we're going to combine this image with the image produced by this tool and use a mask to blend the two together. And you'll see the difference here in a minute. I selected 50 levels. This does take a few seconds to crunch, so we're at level 10 now. For those that are familiar with PixInsight, there's also a tool in PixInsight that does this. It's a multi-scale tool. I forget, multi-scale transform, I think is what they call the tool.
Multi-scale median or linear transform, yeah.
So how do you know what detail levels, like how many to pick? Like you went with 51.
The short answer is through experience. The slightly longer answer is the bigger you make the window size, the more you emphasize big detail. The bigger you make the number of detail levels here, the less of a dark band you will have around the detail that you're attempting to sharpen, or emphasize, I should say. It's a little bit of, you have to work with the tool to get used to it, to know that answer. Matter of fact, if what I was interested in sharpening was the real fine detail in here, I would actually use almost the default settings of around 20 for the window size and probably 10 for the number of layers. The other thing you can do with this tool, again, not the purpose of tonight's session, another session coming up, I'm going to concentrate on this tool. But the consolidate detail levels, what I'm doing here is all of the detail levels will be consolidated into one layer or one level. And there'll be one other level called the residual that's left, which is just the residual brightness. You don't have to check that. And then you can take all of those layers and you can emphasize any particular detail layer that you want. You can sharpen it, brighten it, do whatever, and then recombine them all again. That's a rather advanced technique that is really good at bringing out fine detail, but it's not something we're getting into here tonight. So now you can see it, the tool is finished. We're going to open the two levels that it has produced because I've consolidated all the detail layers. And here's the detail layer. Here's that black band that I mentioned around the galaxy. Here's the overall brightness. So you can see you got a dark background. It's brighter where M81 was. It's not quite as bright where M82 was. We're not interested in the residual layer here. We'll get rid of that. Now what we're going to do, we're going to combine this layer and this layer. And the type of combination we're going to use is a blend mode that is specific to ImagesPlus. And I'll get rid of the stars out of this here. It is called the merge split blend mode. So whenever you take an image and you split parts of it out, merge split is designed to put it back together. Now we'll let it put it back together here. Now, for those that are familiar with Photoshop, this is the various layers. It doesn't have the fancy interface of Photoshop where you actually have, you know, pictures of the images, but these are now the two layers that we're combining. You can see what it did. It produced an image, but it sort of blows out the core. So now what we're going to do, we're going to make a mask out of this image. It's a luminance mask. We're going to use the custom luminance mask function to make the bright cores dark. Where's custom luminance? Right here. Remember, we talked about this one before. And all we're going to do, we're going to slide this down so that the cores become a little too far. We're just getting rid of the cores. And we'll use the feather adjustment to sort of blend it together a bit. That's not too bad. We get a little more than that. A little bit more yet. That's pretty good. And then I'm going to blur this mask. I'm going to blur it quite a bit. Oops, sorry about that. I have the wrong blur function selected. I have to wait till it finishes. 1 sec. We want a Gaussian blur. Then I can select a bigger blur. Okay, that should hopefully be enough. We're going to add the mask to the, I'm pointing at my screen again, to the top image. So you click Add Mask and you just click on the mask. Now watch what happens. If I did that right, we should preserve the core of the galaxy. There we go. So now we've greatly enhanced the galaxy relative to the background. We got rid of the dark circle that was around it because the mask is dark in that area. Right, and if you look at, here's the original, if I shrink these down to the same scale. Come on, get over there. So now you should be able to see the difference now in the galaxy. There's a fair amount of more detail in this galaxy, and the spiral arms have brightened up quite a bit. Can you see that relative to the original? Okay. So now we can go one step further now and add the stars back in. So we just click Add Image. And if I go up here, I can find my stars. There they are. And you click on the image. And now it's going to put the stars back in, and the stars should also be set to merge split. Wait till it crunches.
The one
And
you're
there we
adding
have it.
always go to the top, right?
What's that?
The one you're adding always go to the top.
They stack in this order. So this is the base image. So what it's going to do, it's going to combine this with this using the mask, and then it's going to combine that with the result,
Okay.
just like it does in Photoshop. And take a look at the difference here. If we flatten that, and what I'm going to do, I'm going to close this down. I'm going to close this down. I'm trying to get back to my original image. Bear with me. We don't need the detail up anymore. So here's the original image, and I'm going to undo the feature mask on that image so that we get back our original image with stars. Looks like I have to go back a little further. More. Having an infinite number of undos is quite nice. It does, however, gobble up a lot of disk space, because the way it does that is it actually stores, for each one of these, it stores what it did to the image and the result. So when I go back, it's just pulling up that previous result. When you're done, it deletes them all, by the way. So now take a look at the difference. Here was the original. Here is the sharpened and enhanced galaxy compared to the original. You see the difference? Hopefully it translates into zoom. If I, pardon the pun, zoom in a bit and do the same to this image. Can you see the difference there?
Yeah, sure.
Right. So it's nicely sharpened.
Yep.
Right. The background is still nice and smooth. The stars look pretty good. We're getting pretty close to what we might consider the final image that we just want to set the black point on. So that gives you an idea then of how you can use masks with the layer tool to, and by the way, there are two layer tools. I don't know if you noticed them. One combines all open images. It will just open the layer tool and put all of the images in it. The other one, called manual combine, that opens the layer tool and doesn't put any of them in. You have to click the add image button and click on each image that you want to add. They both open the same tool though. So that gives you an idea now of how I could use a mask to limit the enhancement just to the galaxy. And I also preserve the core of the galaxy. There's one more very nice use for masks that I want to show everybody here tonight. It works in Photoshop. It works in almost anything that supports masks and layers. If we take, we're going to go take this image, and it would be really nice to be able to really stretch this image, which I'm going to do. I'm going to try and do. Now we'll use curves. What the heck? and turn the background down a bit. Okay, now, although it's bringing up the noise, whoop, a little too much. Not the best stretch for this. Bear with me. We'll try one more. We'll try a different stretch. Let's see. Stretch. General stretch. This should work. Let's see. It's getting there. What I'm trying to do, I want to take this and brighten it up to the point where I lose a lot of the core detail in the galaxy here. There we go.
There.
And then if I turn the black point down a bit, I'm attempting to pull out as much of the IFN here as I can. There, can everyone see the IFN now in that image all around here, you know, in this area? Hopefully you can see that. Okay, so there's the IFN in the image, but look what happened to the galactic core, right? It's a piece of crap. So we're going to do something with layers and a mask here. I'm going to duplicate this image first off. And then I'm going to undo the stretch on the first one. Okay, so now we have two images here. We have one image that has all the galactic detail, another image that's lost a large part of the galactic detail, but it's got all this nice IFN that's much more visible. Wouldn't it be nice to be able to combine those two in an easy way? Turns out there is an easy way to do it. What you do is you use the combine all open images functions with blend modes selected. And you open the tool here, and I just have to find out which image is which. Bear with me. We want this image on top. Yep. You want the image that does not have the galactic core on top. So we just highlight the image you want, and you hit this arrow to move it to the top of the stack. So now the next thing I want to do, though, is I want to make a mask out of this image. So that the one that's really bright, as far as the galaxy is concerned, I'm going to make a mask out of it. And then I'm going to blur the heck out of that mask. Actually, tell you what, before I say that, I won't blur it just yet. I'll show you why. Now, remember this top image is the one that has all the galactic detail. The bottom image in the stack is the one that has all the IFN. What we're going to do, we're going to take that mask and we're going to apply it to the top image. So we made a mask out of the bottom image that has all the washed out galaxy. Oops, I need to select the mask. And we're going to apply it to this image. So you highlight the image, you click Add Mask, and you click on the mask. So now you notice it says mask enabled here. So it's got a mask on that, and it's redoing that combination. We'll wait for a second or two. And that is not the what did I just do wrong there? Bear with me. There's that one. There is, oh, I see what I did. A minor bug in the tool. Sometimes you have to just move the opacity slider to see the correct image here. Just bear with me. There we go. So now take a look at this. We now still have the IFN. we have most of the galaxy detail, but you notice the contrast in the galaxy has gone down quite a bit. Now we're going to blur that mask. So we click on that. We click on mask to pull the mask in. Then we're going to blur that mask quite a bit. And again, this works really well in Photoshop too. If it's basically doing an HDR image out of the two images put together. We can blur that even more. There we go. Now when we click apply, we should get all the contrast back in the galaxy, but we should have all the galactic detail in the core. So you can use a mask. There we go. Now look at what you got. So now you have all the IFN from the really overly stretched image, but you have all the galactic detail from the other one. So if we go and say, look at this image, hopefully I can make these small enough that you can get them both on the screen here. Bear with me. There we go. So that's probably too small because now you can't see the detail. There we go. And then we'll take this up to 15%. So you can see that this one has all the galactic detail of this image, but look at the enhanced IFN from the other image. Right? So what I've done is I've stretched an image two different ways. One to show me detail in the faint dust in the field, the other one to show me detail in the galaxy, and then just by using a layer combined with a simple mask made from the blown out image, I get a combination image that looks really sharp. The stars aren't bloated, they get the stars from this image, but I get all the IFN detail from the other image and I still keep all the galactic detail, right? So you can do that with two different images, two different exposures. So I could have a 1 minute exposure and a 20-minute exposure as an example. You know, if you're doing the Orion Nebula and you want to get the faint outer areas, plus you want to get the trapezium and all that area, you take a shorter set of exposures for the inner area, the trapezium. You take a long exposure for the outer areas, and then you combine them exactly this way to get a combination of both. You can see the difference in the two images, right? At least I'm assuming you can see the difference there in, there we go. So you can see lots of IFN detail here. It's there, but not nearly as enhanced. And the galaxy is still very nice here and here. All I do with this image now is I would darken the background a little bit, one more noise reduction pass, and probably tweak the color a little bit, and I'd have a finished image. All courtesy of masks.
Very neat.
I think that's just about everything. Any questions?
This is going to be better when we review it, I suppose.
Oh, I suspect it will. Jerry, I'm assuming you've been recording this?
Oops.
Absolutely.
Yes, I have.
I'm glad you said yes, because otherwise we have to go do it all over again.
It will
at
take
that-
a little bit to get it out there, but because it's
Yeah.
a long recording. But,
Yeah, but you can see that we now have an image that has some IFN detail. And matter of fact, we could probably, at this point, there's that blown out core.
Yeah.
We could probably use an inverted luminance mask now, Jerry, that should pull out some IFN detail. I
Yeah, I
hope.
can see it better now.
Let's see if I can pull that out a bit. And then maybe take the whites up a bit. Ooh, that's black. I want white. So now you can start to see some of the IFN detail that's in there. Now, if I were to use that as the mask to pull the brightness down a bit, it would actually help enhance some of the IFN a little bit more. I won't bother because we're pretty close to the end of what we do with this image, but you get the idea. Okay. Any
Blair,
other
you said you-
questions?
Yeah, you were going to do some tweaking of the color before you put this guy to bed.
Oh, yeah,
Can you step through just quickly how you do that
sure. So let's take this image.
without screwing everything else up?
Yeah, that's no problem. Let's, okay, first thing I'm going to do, the noise reduction that we did, I used a frequency-based filter, and you notice it left a little black edge here.
On all the way around. Yeah.
All the way around? Yeah, I'm just going to crop
Yeah.
that out just to make the histogram look a little better here.
Mhm.
There's no need to. You can do it without doing, you can correct the color without doing this. It's just annoying when you look at the histogram with that there. So here's our image. Let's darken the background just a little bit to begin with. So now we have a more normal looking histogram without all the crap here from those dark bands. And we'll just take the background down a little bit. Okay. I've taken out some of the IFN, but it shows the color a little better here now. So now let's say that we want to enhance the blue in the spiral arms. Okay, so the first thing we're going to do is I'm just going to duplicate this image simply because the way this particular mask tool works, it will change the image. Mask function, selective color luminance, and we're going to click on something in the spiral arms. So now we've got an image of a mask that doesn't really have the core, and it's just showing the outer spiral because that was the blue area in this image that I clicked on. Okay, we can, in actual fact, it's green. We can take that and maybe feather it into the blue a little more. And just feather it this way a little bit too. And then we'll blur it a bit just to sort of take the noise down a bit. There we go. Now, that's next thing we want to do is we want to cut down what's in this area because that's the core area. So we're going to take the brightness slider, take this down a bit. There we go. So now the core is gone. We just have the outer area here. We can take, we don't really want to get all of this crap out here, which is really part of the IFN and part noise. We don't want to get too much of that. So what we'll do is we'll take the minimum slider up a bit. I have to go further. That didn't do anything. There we go. So now we have just the spiral arms and a couple of leftovers from some stars that were in the image. We'll smooth it out just a little bit, just sort of blend things together a little better. There we go. And what I would do as the last step here, I would haul up the paint tools and paint out those stars. So we don't want that one. We don't want that one. That one. Don't really want that. That's not too bad there. Now, the only other thing is I probably should have adjusted it slightly better to make all of this area a little darker. So I'll just use a curve to set that for now. Let's see. And then we'll just brighten up the bright stuff a bit. That's not too bad. I'd be a little more fussy if I was doing this. There we are. So there's a mask that just highlights the outer spirals, right? I would even paint this out because I'm not really interested in highlighting the blue in this galaxy. So let's get rid of him as well.
You'd do the red there, would you?
What's that?
You do the red on 82?
I don't honestly know. I'd have to take a good look at it.
Okay.
Just what I'm showing here is how I would enhance the blue in the
The blue,
spiral
yeah.
arms. So now, the one thing you notice, as I showed you before, the color or the selective color mask tool doesn't leave the image as a mask. It leaves it as an RGB image. So you have to use the luminance mask tool to make a luminance mask out of it. Dumb as that sounds. It's a boo-boo on Mike's part. So now we have a mask that really just highlights the spiral arms. Now what we want to do, we want to take those spiral arms and we want to make them a little bit bluer. So we're going to go to the color tools. There's a variety of different color tools to do this. The one I happen to like to use is this guy. So we're going to make the whole image just a little bit bluer. Okay, that's not too bad, just like that. But we don't want to make the rest of the image blue. In this case, we probably did from the looks of it, but we just want to make the spiral arms a little bluer and enhance them. So now we're going to add that mask. And then we can further adjust the amount of blue that we have added. Get rid of that. So now let's see what that looks like if I undo the adjustment. See the difference?
Yeah.
Right? So I've turned the blue up in the actual spirals just by using a mask to limit it to just the spirals. But the only other thing I would do then would be to take the green down a little bit. For those that are familiar with Photoshop, this tool is the equivalent of Hasta La Vista green or red or blue. You can take any particular color you want down. And we'll take the green down in these areas a bit here. There we go. So now you have a galaxy that's got nice blue spiral arms that everyone seems to like, even if they're not real, which they're not. The next thing we would do is go in and enhance the red in here as well. You'd actually paint that mask. So what you would do is you would go in and say, well, there's a red dot right there. I'll paint a white spot over it. Right? And then finally make a threshold it and make a mask out of that. And you'd only have dots where the red is, blur it a little bit, and then turn the red up just like we turned the blue up. Does that answer your question, Bob?
It certainly does, Blair. Thank you.
So you see now we have nice blue spiral arms. Like I said, they're completely fake because spiral arms in galaxies are really not blue. They're just slightly less red than everything else. But this is what people tend to like, me included, for a nice, pretty picture. And
That's a
it's
great
one of
picture.
the reasons that I don't go nuts unless I'm doing scientific imaging, which I do from time to time, worrying about whether things are linear or not. The simple fact is it does not matter. You know, like if we look at this galaxy, for instance, I'm just going to crop a section out to make this process a little quicker.
Okay.
We'll just crop the galaxy. Okay, now, I think everyone will agree that by this point in the processing, this galaxy is not in any way, shape, or form linear. It's had nonlinear stretches, it's had blurs, it's had all sorts of stuff applied to it. But if I go in and I say I am going to do some deconvolution, hopefully I don't push it too far here, we'll soon see. Use artifacts times 10. And we wait for it to finish. You will see that the galaxy has been sharpened. Is it exactly mathematically correct? No, but I'm doing a pretty picture. It still sharpened the galaxy, right? You notice I didn't even pick a point spread function that's a star. I just picked a Gaussian that happens to be 9 by 9 pixels. And I could have picked a star if I wanted, but why? I'm sharpening the image and a Gaussian works just fine. And the nice part about it is I can play with the Gaussian and get whatever sharpening I want. For instance, I can really go nuts and have a Gaussian that's 17 and see what that does, aside from really make a mess out of the image. Tightens the stars up quite a bit, as you can see.
Yeah.
Right? So this whole concept of saying it must be linear to do some operation is simply not true. It's true if you want a mathematically accurate result. If you want a pretty picture, it does not matter. So, is it mathematically correct? No, it's not. Can you see anything in there aside from the fact that I used way too big a Gaussian and my stars are a little abrupt? It still sharpened the galaxy quite nicely, right? So if I turn that down, you can see the difference. If you're looking in this area of the galaxy, you'll see it sharpen right up, at least if you weren't looking on zoom. So there it is sharpened, here it is unsharpened.
Okay.
Can you see the difference across zoom?
Somewhat.
Yeah, I
Slightly,
figured,
yeah.
yeah, I figured it would be a little bit of somewhat. The other nice thing by using the process history is I can vary the opacity of that change. So I can play around and get just the effect that I want. But that'll give you an idea of, you don't have to be stuck to any particular workflow. It's whatever works for you is what it amounts to. There's nothing wrong with doing it in an order where you do all your linear processing first and then apply your sharpening and then do other things. There's nothing wrong with that at all. It's just not always necessary. Okay, any other questions?
I'm looking forward to this.
Well, that was great, Blair.
Glad you liked it. Bob,
Yeah.
I'm sorry I didn't use your image tonight. I had intended to, but since I had mine up, I figured I'd just stick with it.
Yours is a much better picture.
Same target.
Same target.
Yeah, yours actually turned out pretty good when I did some of this stuff to it. Bob was up here a few weeks ago now, and we were sorting out an imaging problem for him, and he was imaging this target for my driveway.
And it sure looks a lot better here.
Any other questions? Yeah, this was shot at St. Croix, so it's got nice dark skies, and
Yeah.
that's the only reason the IFN is visible in a 2-hour exposure is I did it at St. Croix as opposed to my driveway. Any other questions?
Thanks, Blair.
Time to practice.
Okay, well, at least you're all awake. I did well.
Yeah, well, looking forward to this for a while. It's the
Brain
next
hurts a
step.
little bit.
Yep. So the next one of these we do, I'll pick another tool. So we've gone over sort of at the beginning, we've gone over general workflows, how to stretch images, that sort of thing. We've now done masking in more detail. Probably we'll do one on sharpening. We'll do one on some of the more interesting tools here for flattening backgrounds and that sort of stuff. Those will be short sessions that I'll probably combine into one. So we'll be looking at, we'll do one session on layers and combining. We'll do a session on multi-point flattening a background. This, by the way, is similar to dynamic what do they call it in PixInsight? Dynamic background extraction or something?
Extraction, yeah.
Yeah, this does the same thing. It allows you to flatten the background and remove gradients. It is a little more manual, but does a good job. We'll look at some star size and halo reduction techniques. I'll sort of quickly go through the other menu items as we need them in an upcoming session. And we'll even take a look at some of the blurring functions and sharpening functions that are in here. This one, a lot of people don't realize it is actually quite useful. It's designed to take out hot and cold pixels. But for anyone that has sharpened an image and they find that their image has those sort of really bright points in it that really aren't real, it also removes those quite nicely. So we'll take a look at using it for some of that stuff. We'll look at the sharpening functions, and then we'll do something on colors on another night. And that will give a good overview of ImagesPlus. There are a few functions left, like, you know, histogram and line profiles and that sort of stuff, but they're pretty straightforward to play around with. Okay, thank you, folks.
Thank you.
Super, thank you.
Yeah, glad you,
Thank you.
hopefully you found it useful.
Absolutely.